Hello everyone. I'm Amulya BR of Sri Venkateshwara College of Engineering and I belong to the branch CSE AI. So today I'm back with another subject called machine learning and on the topic end-to-end machine learning projects. So now let us look into the contents what we are going to learn today. The contents are Introduction to End-to-End Machine Learning Projects, Defining the Problem Statement, Data Collection and Pre-Processing, Exploratory Data Analysis, Feature Engineering and Selection, Model Selection and Training, then Model Evaluation and its tuning, Model Deployment and Monitoring, Maintaining and Updating the System, and the conclusion. So now let us look to the introduction to end machine learning projects. End-to-end machine learning project will encompass the entire process of developing a model for machine learning, from data collection and pre-processing to model training, evaluation, and deployment. So these projects will start with defining a problem and gathering the relevant data. The data is often cleaned and transformed to prepare the analysis, and then a suitable machine learning model is being selected. It is being trained and evaluated to ensure that it will meet the performance metrics or the criteria. And then finally, it is being deployed in an environment where it can make a real time predictions with maintenance to ensure its effectiveness. So, this is an overall introduction or an overview. So let us move to the next slide, that is defining the problem statement. So defining the problem statement in machine learning will involve clearly articulating the issue that we are aiming to solve. It should also specify the objective and the desired outcome, such as predicting any future sales or detecting any fraud or etc. The system should include the context of the problem, explaining why it is important. It should also identify the stakeholders, like who is going to use the model, and also should identify the benefits from the solution. Finally, the problem statement should outline the limitations to be considered while doing the project. And then let us move to the data collection and pre-processing. So in this it is of two divisions, that is data collection and data pre-processing. So what is data collection? Data collection involves gathering all the relevant data from various sources like some databases or external APIs, or be it from web scraping or any other types. Data pre-processing will involve cleaning the data by handling any sort of missing values or duplicates and then transforming it to a normalization and scaling it. Feature engineering includes feature selection and creation. It is performed to enhance the data set predictive power. So, data transformation will transform the data into a suitable format for modeling, including the engineering, like feature engineering and scaling. Now, let us move on to the next slide, that is exploratory data analysis. So EDA, that is exploratory data analysis, involves examining the data sets to summarize the main characteristics. So it will often involve some visual methods, like be it a pie chart or a bar graph. So something like visual. Then EDA helps to identify patterns, or it will detect any anomalies if it is present, and it will display it through the statistical graphics like plots or any pie charts. It also provides insight to data distribution, and also it will specify the relationship between the various variables that is being involved. And EDA also aids in performing any hypothesis. Overall, it is a crucial step in understanding the data before applying machine learning algorithms to it for making any predictions. Next, let us move on to feature engineering. Feature engineering and selection. So feature engineering involves creation of new features or modifying the existing ones to improve the performance of machine learning model. So this will also include techniques such as log transformations or any generating meaningful predictions. Feature selection aims to identify the most relevant features by removing all the irrelevant ones or the redundant data. So this will enhance the model accuracy and reduces overfitting. Then next let us move on to model selection. Model selection involves choosing the appropriate machine learning algorithm based on the problem type, the data characteristics, and the desired outcome. So, this will also include comparing different types of models like linear regression or decision tree or neural networks and evaluating the metrics such as precision, accuracy, or F1 score or recall. Training the model entails feeding it with training data so it can learn the patterns and relationship within the data. And then the final chosen model is validated on a separate validation set to ensure it generalizes to the new or unseen data. Now let us move to the model evaluation. Model evaluation will assess the performance of trained machine learning model using metrics like accuracy, precision, recall, or F1 score to measure its accuracy and effectiveness. It involves comparing the model's predictions against the actual outcomes on validation or a test dataset. Then tuning comes. Tuning the model focuses on optimizing its hyperparameters like through techniques like grid search or random search, we can do this. This iterative process will aim to improve the model's prediction accuracy and generalizability. Next, let us move to model deployment and monitoring. Model deployment involves integrating the trained machine learning model into a prediction environment where it can make real time predictions on the new data. So, this will often utilizes tools such as Flask or any cloud platform such as AWS or Azure for scalability and accessibility. Then, monitoring the deployed model involves tracking its performance metrics and detecting or degradation in its predictions over time. Continuous monitoring ensures that the model remains accurate and reliable, prompting the updates. Next, let us move to the maintaining and updating the system. Maintaining involves monitoring the performance, handling any data drift, or adaptability to changes, and many more points. First, let us see the continuous improvement. So, it will regularly review and optimize the end to end machine learning pipeline to enhance the performance of it. Then, adaptability to change. So, this ensures that the system can adapt to evolving business needs or any regulatory requirement. And updating the models. Implement regular updates to incorporate new data or improve the feature engineering based on performance feedback. So these are in some advantages of maintaining and updating the system. Next, let us move to the conclusion. The journey through end-to-end machine learning project from the problem definition to the model deployment, it is a structured process which is very crucial for deriving any meaningful insight to make informed decisions. Data collection and pre-processing will lay the foundation, and exploratory data analysis or the EDA will provide crucial insights by plotting any graphs. Feature engineering and model selection will enhance the predictive power of the model, followed by the evaluation and tuning the model, which will optimize the performance of it. And then at last, we have the deployment of model monitoring and its maintenance, which is very much critical to ensure that the model remains effective and relevant in the real world applications. I thank each and everyone for watching the video completely till the end. I also request you to please like the video and share the video amongst your friends. I also will make sure to come back with another video on a different subject. Until then, have a good time. Thank you.